go ahead and get started. My name is Jeff Sloan. I'm the brand manager, brand VP of CompositesWorld. You probably know me mostly because since 2006 until a year and a half ago, I was the editor-in-chief of CompositesWorld. I was asked to do this, quote, fireside chat exit interview with Dale. We're gonna reflect a little bit on how Dale got to this point in his career, and I want to get some thoughts from him about the future. Also want to recognize Scott Francis, who's now the editor-in-chief of CW, who's going to be shooting us here up on the stage. So a little bit of context. I became editor-in-chief in 2006. I came from the plastics manufacturing industry for a trade magazine there. I thought polymers, pretty much the same. Came to the composites industry, of course, is totally different. So I was drinking from the fire hose for a long time. Met Dale very early in that process because Dale had already started writing for CompositesWorld and previous to 2006. And CompositesWorld was founded by a person named Judy Hazen, who I think some of you knew. And Judy started CompositesWorld in 1993 and had established a relationship with Dale where Dale was a contributor to the magazine. So we're going to talk a little bit about some of the stuff Dale did for CW, talk about his work history, and then a little bit about the future. So Dale, what I want to start with is a quick summary of your work history. Everybody in this room, I think, just needs to understand when it began, where it began, and your evolution up to this point. And if you could do that in about 2 minutes, that'd be great.
Yeah, I think I can cover that in 2 minutes. No, I mean, just as a kid growing up in Houston, I lived in the shadow of big chemical and petrochemical and refineries plants, and always felt like those would be exciting places to work. So, I grew up with a father who was a manufacturer, didn't go to college, built things, and always wanted to love that side of the things, making things. And went to A&M, got a chemical engineering degree, and 4 offers out of college. 3 of them were, your traditional geek with the pocket protector and slide rule and stuff, and designing distillation columns and that sort of thing. And one of them was, you're going to be wearing steel-toed shoes and a hard hat and an emergency respirator, so if there's a chlorine leak, you don't die. And you're going to be managing an almost billion-pound a year propylene oxide plant. And so, so manufacturing already being in my DNA that was just so cool to go get to do that. And then that was for Dow Chemical in Freeport, Texas. 4 years later, they had an initiative to bring technical people into the sales and marketing force. And I leapt at that because I'd already been working on my MBA, and I went to Detroit. Got into selling epoxies and vinyl esters in the automotive industry, got the market development there, got infected with the composites disease. And after 4 years there, got out Salt Lake for Fiberite in the carbon fiber and advanced composites business. Got another part of Fiberite made molding compounds, moved to Chicago for a couple years, then back to Detroit. Led the acquisition of a molding compound company in France, went and ran that in the north of France, came back, led the whole molding compound business, and then Cytec bought the company. Became Fiberite Cytec. Wasn't the kind of culture that I wanted to be in, and so I took my leave and became a consultant. While I was a consultant, and I met Judy, we can talk about that in a bit, but she would, because I spoke French, she would have me come to JEC and support their booth at JEC, and occasionally they'd go, "Hey, this one's for you," because somebody couldn't speak English that came up to the booth in those days, and some guy rocks up and he goes, "We've got a new process and you're going to write about it." And it turned out to be Quickstep out of Australia, and that's how my relationship with Quickstep started. And at the time, I was working on a program with GM to manufacture the hoods for the Corvette. We were looking for faster processes to do it. We got engaged with Quickstep, and later on, they brought me on board and established facilities in Dayton, Ohio, just a couple miles away, Manchester, UK, and in Munich, Germany. As that got to be about 10 years with Quickstep, the company was running a little dry on cash and really needed to close down U.S. operations, but at the same time, I was already engaged in the IACMI proposal to the FOA from DOE, and one afternoon after we'd gotten the proposal all wrapped up, and I got a call from Craig Blue and Doug Parks, and they said, hey, if we win this thing, we want you to be our chief commercialization officer. And sure enough, we did win it, and then in January of 2015, I came on board. And here we are, yeah.
Okay, I want to backtrack a little bit to Dow and Fiberite, because I think that put you into a lot of interesting applications and markets. You mentioned automotive. Obviously, Fiberite has a high-performance segment. I'm wondering if you could just talk a little bit about some of the projects you worked on there, some of your the applications, things that stood out to you in that experience.
In the Dow and Fiberite?
Yeah.
Yeah. Well, Dow, I was responsible for a couple of sectors. I mean, we had coatings that epoxies went into, but most of the composite work, we were in two main sectors. One was infrastructure, kind of infrastructure, corrosion-resistant tanks, things like that. There's a lot of that kind of fabrication going on in the Midwest. And then the other was automotive. And we've certainly sold material in production applications and sheet molding compound and so forth. But we're also doing a lot of development work. We were selling, at the time, GM was making leaf springs. We were the resin supplier for that. And I do remember, like, first week on the job, I go down to Chrysler, and there's a chief engineer there, and he says, we're going to, in 1 year, we're going to build a composite car, and Lee Iacocca is going to drive it off the assembly line. And I went right report, get the truckloads ready. And, and so, found out, naively at that point that those guys didn't know how to build a composite car. And honestly, neither did we. We weren't car guys, and they were not resin guys. And so we had to do a lot of learning back then, a lot of prototyping. So I got to prototype, we'd do drive shafts, leaf springs, structural cross members. I was responsible for getting specified for some of the first low-density SMC in vinyl ester for semi-structural applications on Corvette to meet CAFE requirements. Developed with Bud Company the Detroit diesel valve cover that then propagated into passenger vehicles. We actually prototyped a whole monocoque structure of a car. There was a picture I think Chad showed yesterday of me standing, with the front end structure of a Ford Escort that was strain gauge, ran into a wall. All this, it was foam cord with multi-axial fabric and resin infused. Certainly the cycle times were not there to meet automotive rates, but we demonstrated that. As we did all these things, first prototype pickup box. First pickup box actually came out about 8 years after we had prototyped it. So these things don't happen overnight. And then it took until really BMW came out with the I-Series, that resin-infused primary structure of automobiles, came out. And that was 25 years later. So, so some of these things, you do them. It's that kind of expectations versus reality. Yeah. You can show what's possible, but you have to have a lot of patience.
So you mentioned a lot of prototyping, and it sounds like a lot of developmental work. Was this at the behest of a customer, or was this Dow evaluating potential applications and then looking to place them, or what was that work experience like?
Well, you had an industry that was under pressure to improve fuel economy a lot, and so they were exploring all kinds of avenues. And one of the tricks that this industry we'd get into a lot was, well, they've taken steel and aluminum about as far as they can go, and powertrains as far as they can go, and so they got to go to composites, and then 6-speed, 8-speed, 10-speed transmissions, variable cylinder activation, multi-point fuel injection. All these other iterations came along, and it said, well, that was cheaper to do, and something they felt more comfortable doing than trying to retool all these plants to get away from steel and go to composites. We just kept seeing the timeline push back.
So I want to talk a little bit about Fiberite, because that gets you into some high-performance applications, sure. And maybe just talk about some of the projects you worked on there.
Yeah, one of the things, we supplied all the material for the International Space Station truss structures. Those were kind of a wrapped pre-preg tape, toughened epoxy tape that had now been in space for a very long time, and I got to work on that program. I was also working a lot in satellite structures, the conversion from epoxies to cyanate esters, and away from things like pitch 75 to high modulus pan. So that whole conversion of that industry for all the satellite structures and stuff led that transition. And then I did also a lot of work in textiles, textile preforming. Fiberite was the largest weaver of carbon fiber in the world. We wove under contract to a lot of the other carbon fiber companies who didn't have their own weaving capabilities. We also did a lot of textile work in 3D weaving and polar weaving and braiding. And we did a project with GE at the time. They were developing the fan blade for the GE 90. And the experiment we did a 3D woven complete fan blade to shape. It was a 7,000 end jacquard loom, fully woven together with through thickness, like 30% of the fibers went all the way top to bottom, and infused that with a toughened resin, that prototype. It was just, it never went that way because they'd already qualified the tape, but there was really clever things that we developed in that time frame. I also got to play, I didn't go away from automotive roots. I also was able to write the specifications for IndyCar structures that was moving away from them aluminum tubs to carbon fiber. And so the very first Bobby Rahal True Sports car in 1990, I worked directly with championship auto racing teams in Detroit to write the material specification for those. And today they're all carbon fiber. They're built by Dallara right in Indianapolis today.
Yeah. So Dale and I spoke before this just to set some baseline questions. One thing you said was when you were at Fiberite, somebody that said thermosets will be dead. And I'm wondering if you could talk about that one.
Well, Fiberite at the time was owned by Imperial Chemical Industries. Imperial Chemical Industries invented PEEK. Yeah. Okay, and some of the folks here from Victrex, have inherited that. That spun out of ICI and became Victrex. And a product called APC2 still exists. It was PEEK carbon fiber. And this argument that thermoplastics are going to be fast to process, recyclable, and so literally in 1987 or 88, somebody from the UK came over, and just literally told me, it says, in 10 years, there'll be no more thermosets on aircraft. And I had a customer at that time was processing, the APC2 was a Fiberite product because of ICI, that was processing flat panels in autoclave, and it was 10-hour cycle compared to the 2 hours for a thermoset part. And I go, I'm scratching my head, and I go, really? Of course, thermoplastics are progressing now, but they're, it's still a long road ahead for them, but a very encouraging road.
Yeah. All right, so this early experience, I think, takes us, into the mid-90s?
Yes.
Okay.
Yeah.
So I'm wondering if you could just reflect a little
90s.
bit on what the industry was like at the time in terms of acceptance, what kind of hurdles you had to clear in order to get a composite part or structure into an application or accepted by the customer. What was the environment like?
I think there was a lot of experimentation. There was definitely a lot of interest. You still had carryover from the Cold War. And so there was lots of aircraft development going on. And the other thing was happening was the carbon fiber market was growing quickly. And so, now all of a sudden we're starting to develop commercial applications for carbon fiber,
right,
led by sporting goods. But that was driving down the cost of pre-preg and the cost of making pre-preg, which started to expand things. Part of what I was doing late 80s, early 90s, late 80s, was working on the early iterations of automated fiber placement. Yeah. Right down the road in Cincinnati, Cincinnati Machine was developing their Viper. Mm-hmm. And we were working closely with Morton Thiokol at the time. Now it's all part of Northrop Grumman, to buy the first Viper machine, and they had to figure out what the format of the material was. Right. And so as a qualified material supplier to Thiokol, we got involved in figuring out, first tried toe preg, then it became slit tape, and right, we became the initial supplier of that. So there's a lot of debugging going on with that. But I think it was, there was this continued embrace. Aerospace was always more willing to embrace that because, pound of weight savings was worth like $300 a pound. Yeah. And the automotive industry had moved all over the place. Depending on what the CAFE standard was or whatever, it was $5 a pound, then it was $2 a pound, then it was $1 a pound, then it was, we don't know if it's worth anything.
Right.
So.
Okay, we'll talk about CompositesWorld now. So tell me about the genesis of your relationship with CompositesWorld and when you first started writing for CW.
Well, when I left Cytec Fiber at the beginning of '99 and hung my shingle out, quickly wound up some consulting contracts, helping people do market analysis, some merger and acquisition assistance, and so forth. Because part of the reason I left is that Cytec decided to sell off the molding compound businesses to competitors, and I was part of that whole process of preparing the offering memorandums and making the pitches. So I learned a whole lot about divestiture and merger and acquisition. So I was helping people with some of those things like due diligence. But there was a conference trade show, small cap trade show in Chicago. And I was in Detroit, drove over, and I had met Judy before, and so I just got talking to her, told her I was independent, I was a consultant. She says, well, how would you like to write for us? And I got my first assignment, which was a big, we called roundup articles on structural adhesives. Yeah. That was my first article for that. And, you know, I had to do a lot of cold calling with a lot of companies to okay, what's your latest and greatest, and somehow frame all that by chemistry and so forth. And, you know, that went well, and then I started doing a lot more articles for that. And at the time, you had high performance composites and composites technology.
Right, we had two brands.
Yeah, there were two brands in high performance composites. Well, that's all things aerospace and carbon fiber, and anything fiberglass, boat, bathtub, automotive. You know, that was composites technology. Yep. And I kind of in 2003, as the automotive industry was doing all this experimenting with carbon fiber across all these platforms, I pitched to Judy. I said, Judy, I got a carbon fiber story. Well, then it's going to be in high performance composites. I said, but it's about automotive. Right. And so, you know, and I was able to convince her to let us put that into the CT. Yep. You know, and so at that point, we started seeing more opportunities to merge. Now, after the business was purchased by Gardner, later, those two brands remained. I guess what, till about 2014, 2015. Right, 2014. And then 2014. Then they were merged into CompositesWorld, which was way overdue, in my opinion. I agree. You wound up writing more than 150 articles and columns for CW, and which is remarkable. I wanted to talk a little bit, get your thoughts on some of the stories and columns that got the most attention from our audience, the most views. So I'm going to talk about an article first, then we'll talk about your column and how that came about. But the article that got the most views is one we published in 2007. It has more than 17,000 page views, which is a lot for a B2B trade publication. And it was a story you did on the 787 down select. And I'm wondering if you just talk through a little bit about that and that story and how you did it and basically what is it? Help everybody understand what down select means in this context. Okay, so prior to that, a couple years earlier, I got the opportunity to do the same thing for the A380. Yeah. You know, and so I did a 10-page article about and I got this really unfettered access across Airbus to ask all the questions I wanted, and they provided me with lots of pictures and so forth, all the composite applications on the A380, which turned into another half a dozen or a dozen articles of various specific things that wound up on the A380 technologies and so forth. And so it was pitched to me, well, why don't we do the same thing with the 787? And I was, you know, I'd already knew a lot of people at Boeing from my Fiberite days and reached out to a couple of tech fellows and said they want to do this, and they connected me around. And we were able to talk, and when we talk about down select, it was like, you know, kind of like trade studies, materials, you know, how did you pick for that particular application that it was going to be autoclave or continuous pultrusion or something like that, you know, or in some infusion. So why did you pick the technology and why did you pick the material? You take like for the frames of the 787, you know, they could have made those number of ways, including hand layup, but they chose this really nice, you know, neat process with resin film infusion of toughened epoxy using A&P's braid. Right. You know, and that was pretty novel at the time. Yep. And so, you know, how did you come about to that? And so all of those components, you know, and that went into what was obviously a very novel airplane at the time with more than 50% structural content. And having that kind of access and bringing that forward was a lot of fun. You know, because I had been in the industry. You know, I didn't come out of it from a journalism background. Right. I could talk to the engineers as engineers and then take that and try to translate it into the kind of speak that, you know, that everybody could try to understand. It's really, really easy, right? Yeah. All right, I want to talk about your column, perspectives and provocations. So the genesis of this, in 2013, Sarah Black and I were attending JEC. Sarah Black was a longtime editor and writer for CompositesWorld who passed away a few years ago. And we had dinner with you one night. So talk us through your memories of that dinner. Yeah. So that dinner came about. Sarah, I was at the time I was on the Quick Step stand at JEC. And, Sarah, when Sarah came on in the early 2000s, she had no background in composites,
Right.
so, she was always calling me up and saying, hey, somebody sent us this thing and said, it's the first time it's ever been done. Not true. Not true, yeah. But, I'd say, well, tell me more about it, and we'd find maybe some nuance to highlight that maybe this aspect of it was kind of new and novel. But she came, and we became very close friends as well as colleagues, and she came up to the booth and said, hey, Jeff and I, are you available for dinner some night this week? And I said, yeah, Thursday. I can. And she goes, well, you picked a place, Jeff, and I want to take you out, and we'll just talk to you about something. And I picked a place that my wife Sally, who's here, we had discovered by being trapped in 2011 by the Iceland volcano.
Yep.
We discovered this nice little restaurant in Left Bank called Chez Henri, and we went there. We sat in a little corner. It's in a very small restaurant. It probably seats like 25 people. Yeah. And you guys pitched it to me as, hey, we want you to write a monthly column. Write about what you want. We're not going to give you the topics. You just, obviously it would get edited. But then said, let me think about it. Didn't take me long to say yes. And then, then we went forward with it. And you said you could name the frequency. I said, well, let's try monthly. And it went from there. But we didn't know what to call it. And the editor at the time was a guy, Mike Musselman.
Yep.
And my early times with Mike, I remember when he came on around 2004, he and I would get into big arguments about, no, Mike, that's not what it is, the editing and so forth. And I will tell you this, is that good editors will make good writers look like even better writers.
Yep.
And I always appreciated Mike's editing, and subsequently Hannah's and Grace, for my columns, is they still let you have your voice, but make sure that the clarity is there.
Yep.
And so as I was reading back through some of my columns, I go, did I write this? So we did that, and we had to figure out what we would call it. So Mike and I had a conversation. So what are we going to do? And I said, well, I'm going to talk. I'm going to talk about some of the history. And in fact, that's where you guys came from. Was like, oh, you've been in this industry a long time. You can tell us about some of the history of the thing. And I said, well, I don't want to just do that. I want to poke at us. I want to poke at the industry and say we need to be doing these other things. Yeah. And it was Mike who came up with the Perspectives and Provocations title.
Okay.
Yeah.
So this is the column, right? The
Yep.
collection of columns?
All 100 of them are in this
All
book.
right. So everybody can come up later if you want to read them.
Some are really, really good. Yeah.
So
They're all online too. Yeah.
no, it's
Oh,
better. It's better in print, Scott. So I'm going to give you.
This is clickbait.
I went through and I looked at the most viewed columns that you've written.
Mm-hmm.
I've got headlines here for them. So I'm going to just give you a headline and ask you to comment briefly on each one. So the first one is from July 2015, more than 10,000 page views, thermosets versus thermoplastics.
Yeah, I think on that one, it felt like the industry had moved away from one technology necessarily bashing the other and realizing that the two could coexist. Mm-hmm. And that what we were all really trying to do was find ways to improve the end products through lighter weight, longer durability and strength, and the right processes and the right materials would find their way. So I was just kind of saying I think there was more or less a truce in the industry in that the two types of materials could coexist, whether it was in automotive or aerospace or some other market, and they would all find their home. But it was time to stop declaring war on each other and focus on what we're really trying to do.
All right, so we can all get along. Okay, yeah. Next one, March 2019. This is a provocative one. Composites recycling, no more excuses.
Yep. Yeah. Well, I mean, we were starting to see, one of the things, by that point we were 4 years into IACMI and had really been and instigated created a whole bunch of recycling projects and helped some of the fledgling recyclers out there get more exposure and advance their technologies. And I said, basically it was, we don't have an excuse now not to do that. In fact, I argued that if you look at supply chains, one of the elements in your supply chain needs to be the recycling part of it. Yeah. Not just the raw materials coming in the door, but what are you going to do with everything when it's done? And I created a code, code 0 from being easiest, which is just minimizing waste, all the way up to level 5, which was end of life or scrap, and recycling those. And it's funny, I come across people around the world who have just taken that and ran with it and said, here's the levels of recycling. And, it became, something we've promoted as an accomplishment of IACMI, but that was derived for writing that column.
Okay, next one. This is from September 2019, the impact of Apollo 11. So this is a throwback.
Yeah, so when Apollo 11 happened in July of 2019, I was 10 on the precipice of 11 years old. I had a younger brother, 1 year younger than me, and when the landing occurred, we both ran outside and looked up at the sky, and the moon was bright up there, and we say, well, we see them, we can see the astronauts. Of course, neither one of us could, but neither one of us going to admit our eyes weren't that sharp. And, I was in Houston, so, what was affectionately called Mission Control was literally 15 miles away.
Yeah.
It's now the Johnson Space Center, but of course, it wasn't that at the time. And, just the whole fascination with space. And when the 50th anniversary came out, and that was written just shortly after, in 2019, I had gone to the local library and listened to a guy talk about all these things. One of my favorite stories he told about the space program, the space race, the 5% or so of the nation's GDP was directed at beating Russia to the moon.
Right.
Just think about what that would be today, the amount of money you're talking about. But we were spending that kind of thing then. Of course, a lot of technologies came out of the space program. But, some of all the computers on the Apollo mission, are less powerful than this. Again, what we've done there. But one of the things, cute stories he told me, there was a German film called Woman in the Moon, and as the director was interviewing the rocket scientists, so, okay, what happens here? Well, first we do this and do this. When do you launch? Well, when we get up to like step 50, and he thought, that's not very dramatic. And he actually created the whole idea for a movie of the countdown.
Okay.
10, 9, 8, 7, 6. So rather than have a list that goes up, as a list that came down to 0, and at 0, then everything happened. That actually came out of an old movie made in Germany.
Okay, final one. This is one of the last columns you did. You wrote 100 columns.
Yeah.
Nice round number. Carbon fiber in automotive at a dead end, question mark.
Mm-hmm.
Again, provocative. So talk us through that one.
Well, my first column was actually about whether anybody, it was the second one, like who's gonna follow BMW?
Yeah.
In bringing carbon fiber composites to the automotive market.
Yeah.
As BMW completed they created their own supply chain. They made the huge investments, and then we wondered if anybody else was going to step up the plate, and nobody did.
Right.
And and then even by the time we got to 2022, even BMW had already said, "We're done." It's the end of the line for the I series, and a lot of things were happening. Carbon fiber is energy intensive. Sustainability. You got to go to 150,000 kilometers before it pays itself back. Some of those things, and then the other thing is the rise of EVs. Mm-hmm. And so while it's still true, and it's even more, that lighter weight gives you longer range, whether it's an ICE vehicle or an electric vehicle, it's and it's even better. A 10% weight reduction in an electric vehicle translates to a 10% increase in distance. But if you don't have range anxiety, if batteries get cheaper, more ubiquitous, and more dense, you still have that economic trade-off. And that's where his question was, where does carbon fiber really fit in all of this?
Yeah.
And I think that's still the challenge there for all of us.
I agree. Okay, I want to talk about IACMI now. 10th anniversary, obviously a big deal. And we can talk a little, I'd like to talk a little bit about why you joined, and what your expectations were of IACMI and how it might evolve and the kind of impact it might have, and then your assessment of what that reality is, what it actually turned out to be.
Yeah, so, one of the things that I tell a lot of people is that, if you're in an interview and they ask you, how much experience do you have, they've asked you the wrong question.
Right.
They should be asking you, what kind of experiences have you had? Yeah. And certainly, I came from a whole career up to that point being in industry and thinking like industry and moving like industry. I'd never been an academic, never been in government. And so I come in, and and I think the reason I was asked to be the Chief Commercialization Officer was to try to bring that kind of focus to say, we are here not to feather our academic nests or just to write papers and do patents, but it is to get things into the marketplace. And so Shirley came in thinking that we could move at those kind of speeds, and that the industry could just say, you know, boom, here we go, you know, all this money's out here, let's go leverage it. And you know, we certainly ran into the reality of, well, there's still a lot of red tape, bureaucracy, and so forth. In the early days, it was on us. Industry would come forward with projects, and we would be slow to figure out how to get them up to DOE, but they would get approved pretty quickly. And then we flipped the switch on that. We figured out how to get up to DOE very quickly, and then they started, you know, it took a little longer through them. And again, a lot of this was, we were all learning together in those early days of the institutes, because, you know, the Department of Energy was very used to issuing single point funding opportunity announcements, now called NOFOs, but that you defined a project very, very clearly. It was 3 years, here are all the milestones, here are all the tasks, you know, and here's your budget, and then you would just tick the box every bit along the way. And now all of a sudden comes this kind of amorphous thing of an institute where you've got all the money and you don't know exactly where it's all going to go up front. You deliberately want to hold it so that you don't give it all away right away, and you create that opportunity for people to come forward. And so you had to figure out a system by where new projects could come in and get approved and get put into the modifications and so forth. And through IACMI 1.0, we had to learn a lot of things that we think we cleared the way for with IACMI 2.0. But you know, of course, now we're in budget holds and things, new curveballs thrown at us. So those are probably, you know, the expectations versus reality was, while I think we have done fantastic things, you know, we've had to deal with some headwinds along the way.
Yeah. So one of my observations about IACMI is that it creates an environment that allows companies and people to share information in a way that is not normally done. And this, as we all know, this industry is heavily siloed. We all think we have secret sauce, we have secret, you know, the proprietary technologies, and we don't want to share information. But we also know it's important to share information if we want to advance the industry, and you know, the rising tide lifts all boats. And so my sense is that IACMI's done a good job of allowing that. Events like this, at a meeting like this, there's the networking component is as important as, you know, what's happening here up on stage. And I'm wondering what your thoughts are on that.
Well, I think there's two thoughts there. One is if you create projects that have the full supply chain in it, everybody's got their own element of that.
Yeah.
And so, you know, the one that brings some secret sauce, we don't need to know exactly the molecular structure or how it's formulated or whatever. You know, what we do need to do is be able to know how to process it and bring it to the marketplace, you know, and to help you accelerate that development path. So, you know, if you start by building a supply chain there where everybody's got skin in the game, but there aren't really competitors.
Right.
You know, we find that you can get to a successful point there. On the second point, I've always felt like, and this is always the hardest data to capture, and Mike Molnar referred to this earlier, you know, like, you know, we have all these projects and we go spend all this stuff, the formal projects, the stuff we can list and report up and so forth. But, you know, it's the stories I hear from members that we have helped connect, where somebody comes into a meeting like this, you know, walking around, you know, the Air Force Museum and, you know, and start talking, pointing at things, and they just get to know each other, and they run off and do business together.
Yeah.
And there might be millions of dollars of commerce that occur, but there's no obligation for them to report that.
Right.
And we know that's happening, and we're really happy it's happening, and that's the kind of feedback we get from members is like, yeah, I get access to, you know, I'm a small company. I don't even know where to start attacking to find the right point at ORNL or at Lockheed Martin or some of these places, and, you know, and our ability to help them find those access points. And if they go off and you know, and make beautiful music together, that's a real success for us. That is,
right.
You know, for me, that's even a greater success than having some final technical report that came out of a structured project.
So I'm wondering if there are any particularly memorable moments of the last 10 years that stand out for you in your experience with IACMI.
Well, I mean, there's the weather at some of our members' meetings. Yeah. You know, such as polar vortex in Indianapolis, and, you know, and the heat wave we've had here, and things like that. You know, or snow opening in some of our Detroit meetings. when we were doing them in the winter. But the ability just to, I think of the 9-meter blade and then subsequently the 30-meter blade, the chance for me to once again step into a facility, and cut plies and lay plies and put a vacuum bag on and, and do infusion and things like that. That's a great memory for me, and I loved those aspects of it. And being on site at the SURF and, and watching the molding trials, but, just being there and, again, watching things be made, at all of our facilities. That's been super exciting. Yeah.
Okay. Great. I'm going to talk a little bit about the future. A lot has changed, obviously, just even in the last 20 years in this industry. And I want to give you some headlines and ask you to comment on each one and just get your thoughts and feedback. So I'm going to start defining and measuring success.
Amy Kiesler had me address her cohort of interns a few weeks ago.
Yeah.
And, and so I told them kind of my story. And I said, if as a kid growing up, I said I want to work in those things. And if I had tried to define what success was at that point, I wouldn't be here right now.
Yeah.
So, I mean, you can define it, you can try to define it, but it's sometimes a meandering path, and it's not what you expected at the beginning. Okay? And it's a really hard question to answer. I mean, yes, if you're doing a technical project and it says, it's successful if we achieve these things, if we can demonstrate that it cuts costs by 20% and it reduces the energy consumption by 30 and it uses, those are all kind of technical metrics that you can do. But to me, the success is, over the long haul. I wrote a column that we didn't talk about. It was about 3 other P's.
Yeah.
Yeah, and it was about somebody who was in this room, John Bucell, where I interviewed him in I think 2018 at CAMEX, and it was, the title was Passion, Persistence, and Patience, and it was about the long journey that this industry has had, largely, with a large credit going to John about, getting standards for composite rebar, for the ASTM standards, and getting the ACI standards for for incorporating composite rebar into concrete. Yeah. And that journey was a long time. And so to me, we've been successful because of people like John and others in this room, and I'd like at some point maybe myself to be included in that because we took the long view. Mm-hmm. And while we had aspirations of where it was going to go, we might have had to wait a long time. Again, I think about pickup boxes, prototype in 1987 and first sport track comes out in 1994 or something like that, and now they're ubiquitous. Yeah. And I like to think that I was part of that genesis of it. But there are a lot of other people, of course, that, that deserve a lot of credit for that. And, I'm lucky that I've had people come up to me and they'll say, or tell me, hey, because of you, we're able to do this and so forth. And it's really not me. It's them. They're the ones having to really do the hard work and reach into their pocket and make the investments. All I'm doing is trying to help them find the right people to do it with. Okay.
Next, high rate manufacturing for aerospace. So when Boeing and Airbus eventually develop a new single aisle aircraft, they're talking rates of 75 to 100 shipsets a month, which is an order of magnitude more than the 787 and the A350. Yeah. Thoughts on that?
Yeah, rate 14 for the 787 when it gets back to that, or the A350, which probably is back to that after the pandemic. Yeah, that's a whole different kettle of fish. Yeah. Yeah, I sat down and I worked with Airbus. When I was at Quickstep, we were looking at that problem. At the time, we were talking 40 aircraft a month. Right. It was kind of a stretch goal, and now obviously, an 80 aircraft between them, per month. But if you look at the wing skins, which are about 17 meters long, a couple meters at the tip, near the tip, and then like 3 or 4 meters at the root, and you think of the number of autoclaves that they would have to do, even at that time, was 160 wing covers a month, but now you're talking 320 wing covers a month. You know, that's a big hurdle to overcome. You know, the progress that's been made, for example, with the Airbus I guess it's A220 now, the
Yeah.
Bombardier,
Yeah.
you know, with trying to do some of that in resin fusion, I think, you know, points us in a direction that makes a lot of sense. But, you know, it's high rate, that's high rate new single aisle. Thermoplastics probably make a lot of sense for the fuselage, but I think, you know, where you have the big wings and those thick structures, those are still going to be thermosets, and we have to continue to find ways to make those quicker.
Yeah. Infrastructure's been an eternal hope and promise. Thoughts on that?
Yeah, you know, again, referencing, you know, we've made some breakthroughs, you know, on the rebar side, and, you know, and the occasional bridge here and there. To me, that's still possibly the biggest market that composites could have. Right now it's wind, but you know, but infrastructure, you know, if they could adopt it in grand fashion, you know, and get over this first cost hurdle and think more in terms of life cycle economics, you know, would just, you know, make the glass fiber and even the carbon fiber market just explode.
Yeah.
And it's a hard slog, and I don't think it's because we can't do it. We've got one-offs of everything.
Right.
This reminded me of the prototype days of automotive. We've prototyped almost anything you can do, and you know, whether it's, you know, pultruded structural beams or, you know, pedestrian or vehicular bridges, utility poles, all these things. You know, we can do all of those things. We just got to get to the right people that will willing to take the risk and adopt them. And I think we're making headway there.
Yeah.
You know, we're going in the right direction.
We've talked a little bit about automotive already. It's held out as a holy grail of markets and applications for such a long time. And you talked about the i3 and the supply chain that BMW captured there. And when just wondering what your assessment is for the future of automotive and what the potential role is there for us.
Yeah, I think, you know, every plastics company or resin company, it says, well, we want to go in the automotive market. Look how big it is. You know, they build 15 million of these things a year in the United States. And how hard is it, you know, to get 1 pound out of 3,000
Right.
on a car? Yeah, that'd be pretty easy.
Right.
You know, they almost never notice it. It's bloody hard.
Yeah.
Okay. It really is, because, you know, every automotive, you know, you're dealing by model, by OEM, and convincing them. And we sold a lot of material into phenolic brake pistons, for example, when I was at Fiberite. And again, slow, steady progress where almost every car today has a phenolic brake pistons.
Yeah.
You know, have replaced steel because they're just better from a thermal standpoint and a corrosion standpoint. But you had to do that vehicle, by OEM, by brake supplier by brake supplier. And it's, you know, I think, you know, composites have a role. I think where the real breakthroughs are in multi-material structures, and not just steel and composite, but like different forms of composite, continuous and discontinuous materials in the same part, where you have the highly loaded sections. So injection overmolding, compression overmolding, some of those, and multifunctional composites.
Right.
You know, where you integrate things that would otherwise take multiple assembly steps. I remember the economics that were done on the VW liftgate, and they were done by VW for us, showed, you know, by taking 10 parts down to 3, you had a 75% reduction in tooling cost. You had, a 9% lower recurring cost than a stamped steel part.
Okay.
You know, that doesn't normally happen. You normally have to pay a premium for that. But battery enclosures are a great example of where you can apply a lot of multifunctionality.
All right, I want to talk a little bit about applications and markets that are either emerging or maybe atypical for the composites industry. So advanced air mobility, I know Joby's here. Hydrogen storage, commercial space, defense, I know Andrew's here. We talked about the next generation single aisle. My observation is we're getting into applications and markets where composites are not just an option, but they are the option. And I'd like to get your thoughts on that and how you see these evolving.
Well, I mean, just like, you know, composites are really the only option for large wind turbine blades. There's not some material out there begging to, to find it or earn its way on. AAM, these got to fly. If you look at the most composite-intensive aircraft we have today, they tend to be helicopters. And so AAM resembles more like the helicopter market than it does the traditional aircraft market. And so you need to be able to make things quickly, cost effectively. When the Uber Elevate guys came out with the report, you basically got to build things at the cost of a Lamborghini and not the cost of a Gulfstream.
Right.
In order to make that market big enough and make the economics work on it. But we're moving that way, and all of the things that are going on, and if provided we can overcome the qualification hurdles that are out there, point toward new materials that process quickly, and that we can. And I think the breakthroughs in modeling and simulation, and to the degree we can call it virtual qualification of materials, will really help that. Hydrogen. I wrote a card called, Hydrogen, Hope, or Hype. Yeah, okay. Obviously it's a fast-growing market, and we really don't know, in this current environment, where it's going to go.
Right.
But, composites, if for mobile applications, composites are the only solution that make any sense. And, and I think we're doing some novel things in liquid hydrogen storage, because if you're going to use it for air transportation, it really needs to be in a liquid form that you can evaporate. It doesn't have to hold the hydrogen for days on end, like your typical pressure vessel, because it's going to get filled and used fairly quickly. And but we still have some issues to solve there with permeability and insulating it and so forth. But I think that's a big opportunity there. But for hydrogen to be economical, you almost need to make it with free energy. Right. So renewable energy that that would be otherwise excess to the grid. Space and defense, commercial space. Yeah. Anything goes into space needs composites.
Yeah.
I like to think that, that if we ever do, decide to colonize the moon, we ever get to that point, that, you can't ship up a bunch of boxes with it full of air.
Right.
You have to, I think we're going to put 3D printers on the moon. We're going to start building
Make it there.
habitats out of moon dust and sending up polymers and 3D printers to do that. And we'll send up 3D printers that make 3D printers, so that you can have a real factory up there, because $10,000 a pound to shoot something into space is expensive. And, you don't want to set up a bunch of stuff that doesn't pack densely.
So 3D printers making 3D. It sounds like an AI self-awareness thing.
Sounds like, AI software telling you need to use AI.
Okay, I want to backtrack to IACMI because we have a new you.
Yeah.
Jason Gibson, who's going to be the CCO. So tell me a little bit about Jason, the search for your replacement, and what your hopes and aspirations. And this is a chance for you to talk to the IACMI group as a whole about your thoughts about the organization and your hopes for the future.
Sure. So, I made my decision that I was coming to some point like this, January of 2024. So it has nothing to do with any recent events. I informed Chad, our leadership team, back in January 2024. This is coming. This is why. And what I felt at the time was we'd done a great job as IACMI of developing a very competent leadership team and employee base overall. Very motivated, very, very sharp, smart, and good at what we do. Yeah. And so I felt the timing would be right. That I could leave, bring somebody else in, that I'd made the mark that I felt I could make, and leave it, and it would be in good hands. I would be very proud of what I'd left behind, but also proud of what was going to come, and that we would find somebody else that would be something of a name brand, that had their own set of experiences that they could bring and lend to and make their own imprint and leave their own legacy on this organization. Yeah. And that it was under good steerage, but here could somebody come in, and that person had to come from industry as well. They had to have that industrial mindset that was sensitive to the needs of industry, to how they work, what their struggles are, as opposed to, government and academia. And so we made that announcement formally in February of this year, started the search. I got the unenviable task of sorting through all 385 resumes that come across Indeed and LinkedIn, and most of which went straight to a round file. But we narrowed it down and narrowed it down and narrowed it down, and went through. And I'm sure Jason was one of the later ones that came in. But some of the people that were in there probably thought, well, another round. I got to talk to somebody else. That kind of thing. And I think we made the right choice. Jason, super sharp, drinking through a fire hose. Mark likes to, for my Aggies in the room, they'll understand this. From the outside you can't understand it, from the inside you can't explain it. And IACMI's a little like that. When we talk about Integrate, ACE, Metal, IACMI 2.0, resource pool, consortium versus this, there's just so many aspects of what we've become. We started out as this kind of very easy to understand thing under DOE, but we've become a much more complex organization, able to provide value in so many more ways than we were initially. And from the outside, most people, it takes a while to try to get there. And Jason's done a very good job of absorbing that. And luckily I'll be around for a while to continue, in a part-time role to continue to help with that transition and pick up the phone. And if you don't know an answer, if he has to leave a message, it's probably because I'm teeing off on the 15th hole somewhere. But but I'll get back to him, and we'll get it through. But I'm very very impressed so far with what I've seen. We've gone out and visited a lot of our remote sites, Detroit, Indiana, around Tennessee. We're going to Colorado in a couple weeks, and he's going to get a responsibility for all of that stuff, and he'll be hosting the next Innovation Insights. I hope he'll want to continue doing that, and he'll have a big imprint on the planning for next year's meeting, and a big role, I'm sure, in a room like this in Colorado.
Right. Okay. Final thing. Prior to this, I posted on the app a poll, and I asked for some feedback.
I got to see some of those questions. It was interesting, yeah. I'll tell you
Okay.
I'll tell you one I laughed the most about.
You're stranded on a desert island with Dale Brosius, sitting around your campfire one night, enjoying an after-dinner digestive. Dale tells you that he's retiring as soon as you are rescued. You panic. Dale is taking with him 40 years of composites knowledge. It's your job to capture some of it. What one question would you ask to uncover an insight or industry wisdom that only someone with Dale's experience could have? So we got a lot of good answers. Questions. I'm not going to go through them all, including, can I have your contacts for the last 20 years?
Yeah, and your notes.
Yes. But the one I'd like to ask you, what do you see as the premier problem or obstacle to further growth for the composites industry?
In a land of so much opportunity, what do you think is the biggest obstacle? Sometimes it's getting out of our own way, and I mean that from the industry side, the academic side, and the government side, and let folks innovate and try things. Let's not try to put a box, too many rules around how you innovate and how you create. I just remember, the build it and break it method sometimes, the empirical method works, but certainly lean hard on the software tools that we've got, to build it as good as you can right away, but then iterate on that and find low cost ways to do that. Experimentation. Legendary how long it took Edison to get to the light bulb filament.
Right.
He said, invention is 1% inspiration and 99% perspiration.
Yep.
And it comes back to those 3 Ps also of persistence, patience, and passion, yes. Nothing ever important in the world has been done without passion. And we have to be patient, but we also just have to keep hard at it. And so I think the biggest impediment to the growth is ourselves sometimes. Yeah. We spend a lot of time in this industry trying to mimic other materials, oh, we want to be the next, we want to replace steel, we want to replace aluminum. And we have so many advantages over a lot of other materials, and we ought to be showing people what's possible. And some of the classic examples, FedEx, when everybody was sending faxes, Fred Smith says, hey, look, I'm going to do it this way. What would we have done without it? The old Henry Ford saying, if I asked people what they really wanted, they would have said faster horses.
Yep.
And so, so I think we just, we got to keep getting our message out there, and we can't give up.
Great. All right, that brings me to the end of my questions. Is there anything else you want to share with the group? Any hopes, aspirations, good wishes, bad wishes? Anything you want to share?
No, definitely no ill intent. People know my story, know I got thrown a few curveballs as a kid. And I was the first in my family to go attend the university and get the degree. But I'm super fortunate throughout my career. I've had lots of opportunities presented to me, and I've been able to take advantage of them. And they've become all these lifelong experiences where I've accumulated lots of contacts that have become more than just contacts. They've become good friends, and I expect to maintain those friendships for a long time. But people that know me know that I share those friends. I'm not somebody that holds on to companies like, the relationships that we had.
Yeah.
I made sure I introduced you to everybody I could in IACMI and said, you got to know Jeff, and you got to know this, you got to know Gardner, and build your own relationship with him. It's not going to change my relationship with you. Yeah. And, and I think that's one of the things I'm very proud of is trying to help people, understand. I think I do a pretty good job of helping people understand what composites are, what some of these really technical things are, by boiling them down to more relevant types of ways of explaining them. And, and so I have a lot of gratitude for that, a lot of gratitude for good mentors along the way, and the people we work with. I always joke, it's amazing to get to work in an industry full of very smart people.
Yeah.
Yeah. And then, I have to say that I have a great deal of gratitude for the woman sitting there who I met back in 2006. Actually, working for Quick Step, she was with an HR firm. And it's my wife, Sally, and she's been along for the ride. And I remember one of the questions that very on in our courtship, she asked me, what are you looking for? And I said, a woman with a passport that wants to use it. It's one of the things. She said, if you could see me right now, my hand would be way up in the air. And indeed, we tack on trips after JEC and so forth. But she knows how much passion I have for this industry, and how many hours I've worked, and how hard I push, and how much hope I have. And she's been along to encourage me the whole way. And I just want to say thank you to her. Right. At the end, not totally at the end of this journey, but at this station in my journey.
Well, we know that you'll be around, obviously, and I just want to personally thank you for everything you've done for me personally, and for CompositesWorld, obviously, and for the industry. And it's the end of a chapter, but you still have several to go, I'm sure. And so.
Yeah. One thing I do want to say, and when you and I were talking about this, we got a call a few weeks ago. After 15 minutes, we thought, hey, okay, we know what we're going to do. An hour later, we hung up the phone. Right. Because we just started going down rabbit holes. But one of the things that Jeff told me, I always like people when I learned French, it's like, when do you think you became somewhat fluent? When it's when you dream in a language. Right. You start to feel like you're becoming somewhat fluent. But when Jeff came in from his injection molding background, and he started in, and all of a sudden he found out he had a lot to learn. But I think you told me the story about how you were in some plant in Europe, and some guy was trying to tell you something, and like, oh, that's never been done. And you'd say, but you said, no, so and so is doing that and already had it, and it clicked in your mind that you had now become an expert, and you have in this industry. You're one of the industry's experts. Yeah, it soaks in eventually. Yeah. Like I said, I think it's a bit of a infectious disease once it gets in your blood. Yeah, it's a lot of fun. You can't get it out. And I'm not talking about microplastics, but but it is. It's something that gets into you, and you can't stop learning. And even as whatever I know, it's just a fraction of what I can know, and I'm continuing to be a learner every day. So, and I learn from you, sir, as well. Appreciate it. Thank you, Dale. Thank you. All right. Thank you, everybody.